Hello everyone, and welcome to another episode of BMED 202. In this episode, I will be demonstrating how to calculate reaction forces of a simply supported beam using the graphical method. Now, I have two simply supported beams here, and I'm going to demonstrate how to solve for the reaction forces. I'm going to start with the beam that is loaded with 2-point loads. So let's begin. I'm going to start off by drawing the beam, or redrawing the beam rather. It's a 12-meter beam, and in advance I've set up my units so that they are reflecting meters. And as you can see, the precision of my units are to 2 decimal places. I'm going to type 12. The depth of my beam for this exercise does not matter, but I'm going to put 0.5. Then I'm going to put the forces. In advance, I've set up my leader style so that I am able to get the arrow sizes that I want. After doing so, I'll just explode and delete the part that I don't need. Then I'm going to copy this arrow over the next side, and the next thing I'll do is to mirror this arrow so that it's on the top. Then I can now copy it in the respective positions, which is 4 meters, and then 3 more meters. I'll copy this time. So this is how the loads are spaced. I'll now go ahead and label them. So this is R1 and R2 is here. This load is the 3 kilonewton, while the other one is a 5 kilonewton force. So I'm going to just edit this. 3 kilonewtons, while this is 5 kilonewtons. And if you're not so sure how to get the leaders in terms of their sizes and so forth and the texts, please revert to watching the CAD 101 video series. One of the episodes, or a few of the episodes, are dealing with how to do this. Now, once I've drawn this, the only thing that is left for me to do is to put on my measurements or my dimensions. Likewise, if you're not so sure, or if you're not remembering how to do this, please watch the CAD 101 series on my channel. There are some videos that speak to doing this. Now, once you have generated your what we call the space diagram, we are now going to draw our pole polygon, and let me show you how to draw the pole polygon. The pole polygon is the polygon that is going to be instrumental in calculating the reaction forces. Now let me select my default layer. Now the first thing in drawing the pole polygon, we have to firstly use the forces that are being imposed to draw a force line. So this is how I'll do it. The 3 kilonewton force will be represented by a line that is 3 meters in length. Then the 5 kilonewton force will be represented by a line that is 5 kilonewtons in 5 meters rather in length. So this line is 3, this line is 5. Once I've done that, and it doesn't matter the number of forces, I would have drawn 3 lines if it were 3 forces. I would have drawn 1 line if it was 1 force. And all I would do is pick a point by, after selecting the line command once more, pick a point outside of the line to the right as my pole. Now this point will be my pole. It doesn't matter where, how far, but I normally like to keep it symmetrical, meaning right at the middle, somewhere at the middle. So I'm going to connect it to both ends, as well as all the points where the lines end. In this case, it's 1 additional point. If it was 3 forces, it would be 2 additional points. If it was only 1 force, then you would not need this line, since the line would start here and end here. So this is my pole diagram. After getting your pole diagram, you are going to now use your pole diagram to draw your link polygon. And in drawing your link polygon, you are going to bring down the spaces, or bring down the lines that are in line with the force line, or in line with the forces rather. Once you have done that, I may want to bring these down a bit more, so let me do that. You can use whatever means necessary to bring them down. Alright, so once I've done this, these 3 lines that are on the link, or the pole polygon rather, will be used to draw the link polygon. And this is how you do it. You'll take the line at the top and copy it from this end, the end that is touching the force line, and you're going to place it anywhere on this line, somewhere convenient, and it will go in this direction. It will need to stop here, so I'm going to trim. If it's a case where it did not meet, I would have to extend. Now we used this line for this line, and then we're going to link this line. That's why it's called a link polygon. We use the second line to continue the link. We have to zoom in to ensure that it's connecting properly. I'll trim it where the other line cuts. Then I'm going to use this line to continue the polygon, and then it will touch here. Now we don't need to go any further. Once we get this, now we're going to connect this end to this end. Once we do that, we have our link polygon. Now this line is instrumental in finding out the reaction forces. I'm going to copy this line at this end, the right end, and I'm going to place this line back on my link polygon. Once I've done this, I can now go ahead and trim where it passes the force line. Now remember, this is the force line. All of the forces are on this line. So this is representing my 3 kilonewton force. This is representing my 5 kilonewtons force. Right? Now, my reaction forces would be, let me show you. R1 would be from this point to where this line, the new line that I've drawn, will be, which is 4.09, and 3.91 would be the second reaction forces. So the distance from this point to this line that I've brought over is reaction force 1. So since it was represented in meters, we have to now convert it back to newtons. So 4.9 is reaction force 1, 3.91 is reaction force 2, and it is that simple, using the graphical means of finding the force, reaction forces. Now let's do this once more for this beam, and in the interest of time, I'm going to just copy this beam and place it here. I can delete this portion. So okay, so that's it. The process is the same. We can choose to extend the lines down ahead of time. It doesn't matter. We're extending down all the lines that are corresponding with forces. So there are 3 forces, so we extend 3 lines downwards. Then in this instance, there is only one force, which is a 6 kilonewton force. So we draw a 6 kilonewton line, and we'll still find a point and connect it to both ends. But since this is a 1 force line, there's no stopping point on this line, so our link polygon is complete. All we have to do is take this first line, copy it, bring it over to the end here, In this case, we have to extend it. Once we have extended it, we copy the next line to continue the link polygon. Then we trim this time. Then I'm going to use another line type to connect the link polygon. This line now, I'm going to copy this line and bring it back over, and it will give us the reaction forces for this beam. So I'm going to copy, not copy rather, I'm going to dimension the lines so that you see the reaction forces. Now, if you revert to the previous videos in the series, you would have realized that I think it was for episode 8, I solved for this reaction force by means of calculations. If you check back that video, you'd have realized that it was the exact beam with the exact loading, and the answers are the exact answers. And for episode 9, you would realize that these are the answers that I got for reactions 1 and 2. So the graphical means is a very accurate means of solving for the reaction forces R1 and R2 in any simply supported beam. It doesn't matter the number of forces. So if it's 2 forces, we have 2 lines representing the 2 forces. If it's 3 forces, we would have 3 lines representing the forces, and we will just pick a point, connect that point to all the starting point and ending points of the forces. In this case, we have 2 forces, we'll have 3 points. If we had 4 forces, we would have 5 points. If we had 3 forces, we would have 4 points. So that's the drift, and we'll just take these lines to form the link polygon over this side. Then once the polygon is complete, we take the line that is completing the polygon and bring it over to our pole and measure R1 and R2. R2 is from the end to the line that we brought over. Then R1 is from that point, then R2 is from that point continuing downwards. So that is how you solve for reaction forces in a simply supported beam using the graphical method. I hope you grasped this concept, and I want you to subscribe and like and share the knowledge so that others can see. Stay tuned for more videos like this, and see you soon.